Peace be upon you and God's mercy and blessings. God willing, we will see together how I can make or use this time. We will see another circuit together. Our circuit starts by routing the wires from the city box to the local control cabinet, and it enters and looks like this. In this case, I work on the fix. After that, I exit with 3-phase and neutral from the LCC to the protection panel or metering panel and enter the slide link TP of the OTA60 type. This is the terminal block responsible for the shorting and isolating process. We will notice here that each phase has only 2 thermal blocks, unlike the function we explained in the last lecture, which now appears on the screen. If you haven't watched the lecture before, please go and follow it immediately. Then I exit with 3-phase and enter the slide link TP, which is the terminal block responsible for the bypassing process. Bypassing TP is used in the case where I have 2 protection relays or 2 metering devices connected in series on the same CT secondary, like when you have the overcurrent and breaker failure as 2 separate relays connected in series, or for example, when you have the BCU, which is the Bay Control Unit, and the DSM, which is the Dynamic System Monitoring, connected in series. Then I exit to the test switch, and from there to the first device, and then return again to the test switch. Then the bypassing TP, from which I will go to the second device, and finally return with the neutral wire. Now we will start the practical session together, but the most important thing is not to forget our rule. Shorting must be done before isolating. Now we will start the practical session on the city shorting and isolating facility. As you can see, this is the demonstration of the circuit we explained. We mentioned that our circuit starts with a 3-phase current transformer, which connects the wires from the city box to the LCC. It enters the FX type TP. Of course, this is not the type used, but the type used is now in front of you on the screen. After that, I exit from the LCC and go to the protection panel or metering panel and enter the slide link TP of type OTA60. Its function is city shorting and isolating. I exit from it to another slide link TP, whose function is pi passing. From there, I go to the test switch, where I have the ABP-FT test switch. Finally, I have 2 protection devices or 2 metering devices, and here I am using 2 power meters. Very good. Now, I want to talk about 3 things. The first thing is the process of shorting and isolating using the thermal block. The second thing is the process of shorting and isolating using the test switch. The third thing is a tricky point during the process of shorting and isolating. Very good. Okay, at the beginning, instead of the current transformer, I will use the current generator output from any secondary injection test kit, like the Freya 300 or CMC 156. So here I have my 3 phases: red, yellow, blue, and black. Very good. Okay, now I will start injecting 3-phase balanced currents of 1 ampere on the 3 phases with a 120-degree shift between them. But before I inject into my circuit, I need to ensure that my circuit is in the normal position. So of course, here I have the shorting and isolating tips. Their normal position is that terminals 2, 4, 6, and 8 are closed, and terminals 1, 3, 5, and 7 are open. The idea of the open position is that you will find the link on your right side, and for the closed position, you will find the link on your left side. As for the finger type test switch, you will find all the fingers closed. I will start injecting my currents. Here, I have set the ratio on the power meters to be 600 to 1. As we can see, the currents are balanced on the 3 phases. It is blocked on 3 phases. Very good. As for the shorting process, we agreed that you will do it by first closing 1, 3, 5, and 7, and then opening 2, 4, 6, and 8. So I start by bringing link number 1 on the left and make sure everything is in order. Then I have terminal number 3, followed by terminal number 5. Then here is terminal number 7. As you can see, very good. After that, I start opening terminal number 2, and then terminal number 4, then terminal number 6, and terminal number 8. In this way, of course, we saw that I did a shorting on the CT circuit and isolated the power meters from the secondary circuit of the CT. Or, of course, I have the Freya 300 or the CMC 156, both of which are part of the CT secondary circuit. What does this mean? it means that if I had made any step here incorrectly, something like the freesia would indicate that there is high impedance on its circuit, or even the SIM-C would give you a warning that you have high impedance. Very good. So I want to start normalizing the circuit again. I begin by closing before opening, meaning I start by closing numbers 2, 4, 6, and 8, and then open number 1, making sure to check the tightness very well and precisely, step by step, in sequence, ensuring everything is secure and functioning correctly with utmost attention to detail and accuracy. And exactly 5 and precisely 7. This is the first point. The second point is that I want to observe the issue of shorting and isolating through the ABP FT test switch. Of course, here, I have my fingers. I can open the LCT fingers one by one, but we must know that with your fingers, there is always a finger, such that if you open any finger, you will find all its fingers open together. Anyway, now, or of course, this is connected to only one, which for me is this one. So with this move, when I opened mine, what did I do? I did it on the incoming number 1. It is going to meter number 1, and thus the planes here shorted, so they only returned from trail bypassing TP and went to whom? They went to meter 2 alone, just like that. Okay, did I do isolating? No, I didn't do isolating. We agreed that to do isolating, you need to bring your test plug and ensure you are entering the test plug here to isolate the first power meter, and then you connect your test leads here to test your power meter, or if it was, of course, a protection relay. Why do I place the metallic ester and open all the fingers together? This is the third topic I wanted to talk about. The idea is quite simple, guys. When you open a finger alone, for example, you have a finger here, as you can see, you will find that this phase's current has been shorted and cut off from whom? From this power meter or from this protection device. If you short phase number 1, you close number 3. All right? Say, for example, on phase number 1, you closed number 1, for instance. And you started, of course, to close number 3, as we can see here. All right? And then I will start closing number 5. I keep doing this during this process. As you can see, what happened here with the planes here experience something exactly like that. So of course, when you have this, here it depends on the current, like or unlike others, and thus in this case, they might enter for me. They might enter for... Therefore, you must ensure that in this case, when you are doing shorting and isolating, you must keep in mind that you are isolating the binary output related to tripping. So even in the case of shorting and isolating, you can take steps when performing protection relay. As we said, a trip command might appear by mistake. And with this, my friends, we conclude the experiment.